right, everybody, let's take a minute and work out what the domain and range would look like for this example. Previously, we went over domain and range in the parent function of secant theta, or y equals secant x, and now we're going to kind of put our understanding of domain and range to the test and see how we will do. However, before I get too into it, I just want to go over a few symbols for the expression such that. We tend to use the phrase such that a lot when we're using a lot of the set builder notation and whatnot, and trying to describe a domain that has to adhere to a lot of criteria, like follow a lot of rules and regulations, you know? So we'll say like this has to happen such that, or this is this type of number such that. The word such that, I'm just going to show you guys a few symbols that get used. Some books, professors and whatnot will just use ST. Although, to be honest, I don't remember seeing my professors write ST very much at all, but anytime I look online, I see it here and there. So ST is one option. The other option we might see is a colon. So that's another option. Third option, now the ones I would see more often are this symbol. It's like a backwards U, E kind of symbol, you know, like that, or sideways U or backwards E, something like that. And I'm not like, the line is not part of it. I'm just like, I don't know, circling it, boxing it, because I don't want to start putting commas or anything around it. It gets a little too confusing. And then a straight line, like one absolute value bar. How's that? Something like that. And I think that covers all the bases. I don't think I'm missing any of the ones I wanted to go over. But of course, yes, you could even just fully write the expression such that. All right, so these symbols will come in handy. We also mentioned this stands for real numbers, and I already described to you what the real numbers are in the last video or so. That is the set of integers. Then this symbol, it's the same as this one, but facing the other way. This symbol means is an element of. Is an element of. So you might say something like, I'm just trying to keep it really simple, you know. So radical 5 is an element of the irrational numbers. Okay, so it's something that belongs in that set. Okay, that's just some fundamentals for us to get started. I'm going to show you this domain with some crazy notation, but if you were able to write what I'm saying using your own words, and you're not really leaving room for any type of a like a loophole, any little sneaky thing to happen, then you're good. Okay, so let's get this domain going. Right, the domain is going to be, all right, let's do the set where x is an element in the set of real numbers such that x cannot equal the first asymptote, which was 5, and really you don't have to pick the first one, 5 pi over 24 plus how much space is between our asymptotes. Here, it's pretty easy to see that it's 30 pi over 24, or we could remember that it's 2 quarters, which is also 30 pi over 24, or it's half of the entire period. The period here, we worked it out to be 5 pi over 2, and if we find half of that, that's 5 pi over 4, and that's the same as 30 pi over 24. So we're going to do, I'm going to leave everything over 24 common denominator, so plus 30 pi over 24, and I could add that any number, n times, so I'm going to use n. Now, I always would put a comma, so I guess that could also be such that, or we could use the colon. Maybe let's spice it up. Such that, although I think a comma is nicer here. I'm just trying to really force and implement one of the other symbols. And I also think like if you use that for such that before, then we should probably use the same symbol and be consistent. So yeah, I know, I'm all over the place. Such that n is an element in the set of integers, close your curly bracket. That was a lot of me blabbing and explaining. Looks beautiful, like some hieroglyphics. I still like the idea of a comma here. That's what my gut tells me to use because of the way we pause when we say this. And then the range, we're going to work from the bottom up just like before. It's pretty easy. So it's going to be negative infinity until -8 with a bracket. Union, where do we pick up again? With -4, also with a bracket, up, and away, until positive infinity. Infinities get parentheses because we don't ever actually hit them or reach them. So that's the domain and range for this example that we did together. I hope you were able to understand it. I hope you were able to potentially more or less do it on your own. That would be great. All right. Now do your best in the future every time you have to find a domain and range, and just keep in mind that there seems to be a lot of flexibility in how you really write domain and range. You just got to be careful that you don't set yourself up for a loophole in any type of way, so that nobody could sneak in some number because you didn't say it couldn't be that number. But you're going to try to do the domain and range on future examples. We're going to slowly work it in, and we're going to go back and revisit domain and range with sine and cosine, and get more into it with the other functions as well. And we're also going to do a huge graphing review soon. So get used to it. It's not going away. If you feel okay and you think that you can learn the hieroglyphics, then great, thumbs up. And if you think that you prefer just maybe writing it as a sentence or some other way, then put a thumbs down. Okay? See you next time.